this episode, we're going to make identity and access management, IAM, feel like a practical safety system for automation rather than a confusing maze of permissions. Modern pipelines and automated operations frequently need to call external APIs, provision resources, and interact with services that sit outside the machine running the job. Those actions are powerful, and power always needs boundaries, especially when the actor is not a human, but an automated workflow. Machine identities are the identities used by systems, workloads, and automation jobs, and they must be managed carefully because they can operate quickly and repeatedly at large scale. Using IAM correctly means you design who the machine identity is, what it is allowed to do, where it is allowed to do it, and how that access is granted and revoked over time. Beginners often think IAM is simply a list of permissions, but operators think of it as a set of guardrails that prevent mistakes from turning into disasters and prevent compromise from spreading across environments. The goal here is to understand the core concepts and to learn how to reason about access safely when automation is calling external APIs. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Start with the most important distinction. Authentication is proving identity, while authorization is granting permission. A machine identity must first authenticate, meaning it must prove it is the trusted workload it claims to be, and then the provider must authorize actions based on policies and roles. Beginners often mix these concepts and treat any access failure as a single problem, but the operator advantage comes from separating them. If the identity cannot authenticate, the problem is about trust, credentials, or configuration. If the identity authenticates but is denied, the problem is about permissions and policy. This separation matters because the fixes are different, and applying the wrong fix can create new security problems, like granting broad permissions when the real problem was a missing token. IAM exists to make these distinctions enforceable and auditable, so actions are not just allowed, but allowed for the right reasons. Once you see authentication and authorization as separate layers, IAM becomes easier to reason about because you stop treating it as a single opaque wall. Machine identities also differ from human identities in important ways, and those differences should shape how you design access. A human identity is tied to a person, which means it carries risk from password reuse, phishing, and account takeover, and it also carries the need for human workflows like password reset. A machine identity is tied to a workload, job, or system component, which means its access should be scoped to that workload's purpose, not to a person's broad job responsibilities. Operators prefer machine identities for automation because they can be tightly scoped, rotated automatically, and revoked without disrupting human accounts. Another difference is that machine identities can act continuously, which increases the importance of least privilege because any permission granted can be exercised repeatedly. If a human makes a mistake once, the impact might be limited, but if an automated job makes the same mistake thousands of times, the impact can become large quickly. That is why IAM designs for machine identities emphasize narrow scope and strong guardrails. A mature system treats machine identities as specialized tools, not as general-purpose master keys. When automation accesses external APIs, it is effectively crossing trust boundaries, and IAM is the gate that controls what crosses that boundary. External APIs might be cloud control planes, third-party services, or internal services managed by other teams, and each API call is an opportunity for misuse if access is not controlled. Operators therefore treat API access as a set of explicitly granted capabilities, not as a blanket right to call everything. A machine identity that needs to read artifact metadata does not necessarily need the ability to publish artifacts, and a machine identity that needs to deploy to a test environment does not necessarily need the ability to modify production resources. This is least privilege in action, and it is the most important IAM principle because it directly reduces blast radius. If an identity is compromised or misused, the damage is limited to what that identity can do. Beginners sometimes see least privilege as extra work, but operators see it as the main line of defense against catastrophic mistakes and lateral movement. Designing with least privilege also encourages clarity, because you must define what the job actually needs, which often reveals unnecessary actions that can be removed entirely. Roles and policies are the common building blocks used to express authorization, and they are easier to understand when you think of them as sets of allowed actions applied in a defined scope. A role is often a named bundle of permissions, and a policy is a set of rules that grants or denies permissions to identities. Scope is crucial because the same action can be safe in one scope and dangerous in another, such as reading logs in a test environment versus reading logs in production. Operators therefore aim to grant permissions at the narrowest reasonable scope, such as one project, one repository, or one environment, rather than granting broad permissions across all resources. Another important concept is separation of duties, which means that no single identity should be able to both create and approve high-impact changes without oversight. In automation, that often means separating build identities from deployment identities and separating validation workflows from production-changing workflows. This separation reduces risk because compromise of one identity does not automatically grant full control of the delivery pipeline. When you see roles and policies as guardrails with scope, IAM becomes a design tool rather than a mystery. A critical operator practice is avoiding long-lived static credentials for machine identities whenever possible, because static credentials are the kind that leak and keep working. Short-lived credentials reduce this risk because they expire quickly, and dynamic issuance supports rotation as a normal behavior rather than an emergency project. Short-lived tokens are often issued based on the workload's identity, meaning the system evaluates the workload and issues a token that is valid only for a limited time and for specific permissions. Even without implementation detail, you can understand the outcome. Credentials become temporary badges, not permanent keys. This reduces the chance that a leaked token can be reused days later, and it also reduces the likelihood that old credentials remain hidden in logs or caches. Operators also value revocation, which is the ability to invalidate credentials before expiration when compromise is suspected. Together, short-lived issuance and revocation create a safer lifecycle for access. When you design machine identity access with these principles, the system becomes more resilient to human mistakes and to attacker behavior. Another major IAM concept is trust conditions, which are rules that limit when and where a machine identity can be used. Trust conditions can include the source environment, the workload type, the repository context, or other attributes that help the system decide whether to issue credentials and allow actions. This is a key part of a zero-trust mindset, where access is not granted just because something is inside a network boundary, but because it meets specific verified conditions. For automation, trust conditions can prevent a credential from being used outside the intended pipeline environment, which reduces replay risk. They can also prevent privileged actions from running in untrusted contexts, such as when a pipeline run originates from an external contribution. Beginners sometimes assume that once a token exists, it is usable anywhere, but operators prefer designs where tokens are valid only under expected conditions. This is not just security theater. It is a way to constrain blast radius when tokens are stolen or misused. When trust conditions are enforced, identity becomes more than a name. It becomes a verified context. IAM correctness also depends on understanding how permissions are evaluated, because policy systems often include explicit denies, conditional rules, and inheritance that can surprise beginners. A common misunderstanding is to assume that adding a permission somewhere will automatically fix access, but an explicit deny can override a grant, and conditions can prevent a grant from applying in certain contexts. Operators troubleshoot this by thinking in layers. What identity is used, what roles are attached, what scope applies, and what conditions or denies might block the action. They also pay attention to the exact action being attempted, because APIs often require multiple permissions for a single high-level operation, such as listing resources plus reading details. This can create confusing partial success, where the identity can see that something exists but cannot access it fully. Understanding policy evaluation helps you avoid the risky impulse to grant broad access just to make an error disappear. Instead, you adjust the precise missing permission or the precise scope mismatch. Correctness is about precision, not about granting everything. When machine identities call external APIs, auditing becomes essential because automation can do a lot quickly, and you need an evidence trail. Auditing means recording who did what, when, and in what scope, and machine identities must be distinguishable so logs are meaningful. If many workflows share one generic identity, auditing becomes less useful because you cannot tell which workflow performed an action. Operators prefer distinct identities per system or per pipeline category, so actions can be attributed cleanly. Auditing also helps detect misuse, because unusual activity patterns can be flagged, such as a build identity attempting to modify production resources. Another benefit is that auditing supports incident response, because you can trace the actions taken by a compromised identity and estimate the scope of impact. Beginners sometimes see audit logs as something only compliance teams care about, but operators care because audits are how you learn what happened when something goes wrong. A strong audit trail reduces time to diagnosis and reduces the chance of making broad disruptive changes in panic. IAM also interacts with reliability because access failures can break deployments, and broken deployments can lead to risky workarounds if teams are pressured to ship. Operators therefore design IAM to be both secure and operationally workable, meaning permissions are correct, scoped, and stable across time. They also design workflows to fail safely when access is missing rather than trying dangerous fallbacks, because unsafe fallbacks often involve using a more privileged identity. Another reliability practice is to validate permissions early, such as confirming that the machine identity has the required access before running expensive build steps. This reduces wasted time and reduces noise in pipeline runs. It also improves learning because failures occur closer to the cause. When IAM is correct and workflows handle IAM failures responsibly, the delivery system becomes both safer and more predictable. Safety and predictability reinforce each other because predictable access paths reduce the urge to bypass controls. A common beginner misconception is that IAM is only relevant to security specialists, but in reality, it is central to automation operations because every external API call is governed by identity and policy. Another misconception is that the easiest fix for access errors is to grant an identity a broad administrator role, but that solution increases blast radius dramatically and often violates separation of duties. Operators instead prefer to define the smallest permission set needed for the job, attach it in the correct scope, and enforce trust conditions that restrict where the identity can be used. A third misconception is that machine identities are safe because they are not human, when in fact machine identities are attractive targets because they can access systems automatically. Treating machine identities with the same seriousness as human accounts is essential. The operator mindset is to assume that any credential can leak and to design so leakage is survivable through short lifetimes, revocation, and narrow privilege. When you hold that mindset, IAM becomes a set of practical safety controls rather than a bureaucratic hurdle. To close, using IAM correctly with machine identities and external API access is about designing automation so it can act powerfully without being able to cause unlimited harm. You separate authentication from authorization so you can reason clearly about where failures and risks originate. You use machine identities that are scoped to specific workloads and environments, avoiding broad human credentials and generic shared identities. You apply least privilege, clear scope boundaries, and separation of duties so each identity can do only what it must in the places it should and no more. You prefer short-lived credentials with rotation and revocation so leaked access decays quickly and can be shut down decisively. You enforce trust conditions so credentials are usable only in expected contexts, aligning with a zero-trust approach to automation. You maintain auditability so actions are traceable and misuse can be detected and investigated. When these principles are applied consistently, pipelines become safer, incidents become smaller, and external API access becomes a controlled interface rather than an open risk. If you can explain how identity, scope, privilege, and trust conditions combine to protect automation, you have a strong foundation for operating modern systems responsibly.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.